Hello everyone and welcome to the lecture on Amazon Lex. So this lecture will contain all these topics. What is Amazon Lex? Amazon Lex core concepts and terminology, how it works, building bots, an example of how to build a bot, enabling custom logic with AWS Lambda functions, and creating and attaching a Lambda function to a bot alias. So what is Amazon Lex? Amazon Lex is an AWS service designed to help developers build conversational interfaces for application using both voice and text inputs. This allows for creation of interactive and responsive chatbots and voice assistants. The service leverages advanced natural language understanding (NLU) and automatic speech recognition (ASR) technologies. NLU, which is natural language understanding, helps the bot understand the intent behind user inputs, while ASR, which is automatic speech recognition, converts spoken language into text, enabling lifelike conversational interfaces that enhance user engagement. Amazon Lex is designed to be accessible to developers of all skill levels. You don't need to be an expert in deep learning or AI to create sophisticated conversational bots, and this democratizes the development of AI-powered conversational interfaces. Developers can easily specify the basic conversation flow using Amazon Lex console. The service then manages the dialogue, dynamically adjusting responses based on the conversation context. This simplifies the process of creating complex, context-aware conversational flows. So once you have built and tested your chatbot using the console, you can deploy it across various platforms. This includes mobile devices, web applications, and popular chat platforms like Facebook Messenger, allowing for wide-reaching implementation of your conversational interface. Amazon Lex offers seamless integration with AWS Lambda, allowing you to add custom business logic to your bots. It also integrates with other AWS services such as Amazon Connect for contact center or call center solutions, Amazon Comprehend for additional natural language processing capabilities, and Amazon Kendra for enterprise search functionality. Through its integration with AWS Lambda, Amazon Lex provides access to pre-built serverless enterprise connectors. These connectors allow your bots to link to data in software as a service SaaS applications such as Salesforce. This feature enables the creation of more powerful and data-driven conversational experiences without the need for complex backend infrastructure. Okay, now I will be covering the core concepts and terminology. So first one is a bot. A bot performs automated tasks such as ordering a pizza, booking a hotel, ordering flowers, and so on. An Amazon Lex bot is powered by automatic speech recognition (ASR) and natural language understanding (NLU) capabilities. Amazon Lex bots can understand user input provided with text or speech and converse in natural language. Next is language. An Amazon Lex bot can converse in one or more languages. Each language is independent of the other. You can configure Amazon Lex to converse with a user using native words and phrases. Intent. An intent represents an action that the user wants to perform. You create a bot to support one or more related intents. For example, you might create an intent that orders pizza and drinks. For each intent, you provide the following required information: intent name, which is a descriptive name for the intent, for example, order pizza. Then sample utterances, which is how a user might convey the intent, for example, can I order a pizza, or I want to order a pizza. And last is and how to fulfill the intent, which is how you want to fulfill the intent after the user provides the necessary information. It is recommended to create a Lambda function for this. You can optionally configure the intent, so Amazon Lex returns the information back to the client applications for the necessary fulfillment. In addition to custom intents, Amazon Lex provides built-in intents to quickly set up your bot. Amazon Lex always includes a fallback intent for each bot, which is used whenever Amazon Lex cannot deduce the user's intent. Next is a slot. An intent can require 0 or more slots or parameters. You can add slots as part of the intent configuration. At runtime, Amazon Lex prompts the user for specific slot values. The user must provide values for all required slots before Amazon Lex can fulfill the intent. For example, the order pizza intent requires slots such as size, crust type, and number of pizzas. For each slot, you provide the slot type and one or more prompts that Amazon Lex sends to the client to elicit values from the user. A user can reply with a slot value that contains additional words such as large pizza please, or let's stick with small. And Amazon Lex will still understand the slot value. Next is slot type. Each slot has a type, and you can create your own slot types, or you can use built-in slot types. For example, you might create and use the following slot types for the order pizza intent. Size, so which is size with enumeration values such as small, medium, and large. So you are providing the option to pick from. And crust with enumeration values thick and thin. Next is version. A version is a numbered snapshot of your work that you can publish for use in different parts of your workflow, such as development, beta deployment, and production. So once you create a version, you can use a bot as it existed when the version was made. After you create a version, it stays the same while you continue to work on your application. And next is alias. An alias is a pointer to a specific version of a bot. With an alias, you can update the version your client applications are using. For example, you can point an alias to version 1 of your bot. When you are ready to update the bot, you publish version 2 and change the alias to point to the new version. Because your application used the alias instead of a specified version, all of your clients get the new functionality without needing to be updated. Okay, this is a high level workflow. So Amazon Lex enables you to build application using a text to speech interface for conversation with user, and following are the typical steps. 1. You create a bot and add one or more language. You configure the bot so that it understands the user's goal, engages in conversation with the user to elicit information, and fulfill the user's intent. Then you test the bot. You can use the test window client provided by the Amazon Lex console. Then thirdly, you publish a version and create an alias. Finally, you deploy the bot. You can deploy the bot on your own applications or messaging platforms such as Facebook Messenger or Slack. Now I will see how to build a bot. So you can create a Lex bot to interact with users. And so let's see like what are the required information for building a bot. So to build a bot, first, the language the bot uses to interact with the customer, and you can choose one or more language. Each language contains independent intents, slots, and slot types. Next, you configure the intents, the goals that the bot helps the user fulfill. A bot can contain one or more intents such as ordering flowers or booking hotel and rental car. Decide which statements or utterances the user makes to initiate the intent. Next, you have slots which you have to configure, the information that you need to gather from the user to fulfill an intent. Examples of slots are, for example, types of flowers for flower order, start date of a hotel reservation. So this information is like fill in the blanks, and user have to fill in those gaps or the blanks. You can define one or more prompts that Amazon Lex uses to elicit the slot value from the user. So let's say one fails, you can try another prompt. Then slot types, the type of slots that you need from the user. So you have custom, which are let's say list of flowers that a user can order, or you have some built-in, something like Amazon.date for the start date of a reservation. And finally, you have the user interaction flow, the conversational flow within and between the intents. So you have intents like, because to fulfill one use case, it will go from intent 1, 2, 3, 4, 5, and it will come to some conclusion. And this is the flow between those intents. So you can configure the conversation flow to define the interaction between the user and the bot once the intent is invoked. And then you create a Lambda function to validate and fulfill the intent. Tip: when building your bot, consider the user experience and ensure that conversation flow feels natural and intuitive. And one warning: make sure proper testing and validation of your bot is crucial to ensure it correctly understands and responds to user inputs. So this will be one of the example overview from the documentation for ordering flowers. So in this case, we have the bot components. So for example, let's say there's a flower ordering e-commerce site. We are taking one use case, which is order flowers. So intent will be order flowers, and you have slot types. So we have flower types custom, and you have to provide the enumerations, like what are the things that you offer. So in this case, roses, lilies, and tulips. Then you have the slots. The intent requires the following information before fulfillment. So this will come from user, but you have to provide them some of these options, like pickup time, flower type, which is custom, which you have to configure before, and then pickup date, right? And then you have the utterances. So you have to configure the sample utterances indicating the user's intent. So you have to just think about what are the things that user may say, because it can be voice or chat, right? So let's say user probably would say, I would like to pick up flowers, or I would like to order some flowers or something, or order some flowers. Or so based on utterances, you have to give them the right intent or initiate the right intent. Then prompts: after identifying the intent, the bot uses these prompts to fill the slots. So so you have to give them prompt, like once you have identified the right intent, you have to ask the right questions, follow-up questions, like what type of flowers would you like, what type of flowers would you like to order, what day do you want then if they say, let's say roses, then you just fill in, because it should feel natural. So what do you want, what day do you want roses to be picked up, and at what time do you want roses to be to be picked up, right? And then you can have a chatbot, can have a both through either it can be chat or voice. So you can say, okay, your flower type roses, so a bot will say, will be ready for pickup by this time on this date, and does this sound okay? And so the bot will just replace and ensure that all slot values are collected before presenting the confirmation statement to the user. So in this case, you can have an intent which will make sure that user says something like okay or yes, and then you go ahead and process the order, right? So this is the one use case, like one of the scenarios, like in how to enable custom logic with AWS Lambda. So AWS Lambda functions enhance control over Lex V2 Lex bot behavior, and Lex uses one Lambda function per bot alias per language. So these are the integration steps. So you identify the input event fields for Lambda function use. You determine response fields to manipulate and return. You create and script Lambda function in chosen language. Then ensure function returns correct response structure. You deploy Lambda function and you associate function with Lex bot alias via console. And you select the conversation stages for Lambda invocation. Then finally, you build and test the bot. So what we are doing, let's say we have built the bot alias, everything is ready. Now, when the bot triggers, you can have a Lambda function, which will based on the intent. So there can be multiple intents. So let's say order flowers or inquiry about flowers, right? So there can be multiple use cases, like let's say for flowers e-commerce shop. Then you can have one main Lambda function, and based on the intent, this will invoke like a broker. It will moderate between multiple Lambda function. So I'll be showing in the next slide like how the code looks like. So first I'll explain, then I will go like code line by line. So this lambda function, this is in general what this is doing. So this lambda function acts as a router for the Lex intents. Okay, it uses the intent name. So there can be multiple intent from the Lex event. So you have a bot which will trigger an event to the lambda function, and lambda function will consume this event, intent event, and this will determine which lambda function to invoke. So this, as I talked about, this is like a controller, right? The mapping between intent names and lambda function name is stored in an environment variable. So in this lambda function, let's say you have intent 1, 2, 3, like book flowers, order flowers, check about the flower types, check my status, right? So let's say there are 3, for example, and there are multiple lambda functions. So you will just have a one-to-one mapping. Then the router function handles the core logic. It extracts the intent name from the event. So it gets the event, it will extract what is the event intent, and then it looks up the corresponding lambda function name. It invokes the function if it is found, and passing the event data, because everything will have through like event bridge events. Okay, then returns the result of the invoked function. If no matching lambda function is found, it raises an exception, and the lambda handler function serves as the entry point, calling the router function and returns its response. And this design allows for flexible and scalable architecture where you can introduce new intents by easily updating the environment variable. So lambda function has something called environment variables. You can have a key value. So key is intent and value is the lambda function. So let's say you have first is you initialize global Boto3 client for lambda to reuse the connection. Okay, then because you will be calling another lambda function. So this is a controller, right? So this is the entry point. So lambda lambda handler is the entry point, and event is the what it receives. This is a consumer, right? So it will get some data, the payload and the context. So we'll use the event only. Then we call router. So we'll be calling our router function or the controller function. Then we extract the intent name from the event Lex event, right? So we are just passing it. So event, session state, intent name. So what is the intent? So as I talked about, order flowers, check status or whatever, right? Then we have the which retrieve the corresponding lambda function from the environment variables, and we will know which lambda function to invoke. Then we will invoke the lambda function, invoke the target lambda function with original event as payload. So we are calling another lambda function which we got from this name, lambda function name, fn name, right? And then we invoke it, and we pass the whole JSON payload, and then you pass the JSON response from the invoked lambda function. So you will get back a response, right? And then you return the payload. If there is any error, then you raise an exception, but this is just for the error condition, exception condition. Otherwise you return the payload. So this so let's say this intent has triggered, it will get data and it will pass the back to the bot alias. So then it will go from one intent to another. So it will get the data. Let's say book flowers case, right? So it will give what information is to be checked from the user next, right? So it may ask that this payload will return probably like what date, what flowers you want to pick at what time and what day, right? So that payload will go back to bot alias and it will continue to process the next step in the whole conversational flow of the Lex bot. And that's all. Thanks for watching.